All right, welcome to the deep dive. Today, we're taking a look at something that I think a lot of our listeners will find pretty fascinating, counterfactuals. And, to put it simply, we're going to be thinking about what could have been, not what is true.
Yeah, like alternate histories.
Yeah.
Or those what-if moments we all ponder.
Exactly. Like, what if MLK hadn't been assassinated back in 58? Or what if, think about this, what if nobody ever colonized the Americas? I mean, these what ifs, they might seem like just, idle speculation. But the thing is, they're actually super important to how we understand, well, pretty much everything.
Yeah, I mean, think about it. You find counterfactual thinking at the heart of so many different fields. Like, obviously, there's philosophy, but also linguistics, psychology, how our minds work, AI,
Yeah.
even history.
That's right. And our sources today really delve into how counterfactuals are key to understanding fundamental questions across all these areas. But for our deep dive, let's zero in on philosophy, shall we?
Sounds good.
Okay. So when philosophers tackle counterfactuals, they bump into three major areas they got to grapple with. Semantics. So basically, how do we even talk and reason about these alternate realities? Then there's epistemology. How do our real-world experiences justify thinking about these what-ifs? And lastly, you've got metaphysics. That's all about the nature of these possibilities themselves. Now, for our deep dive today, we're going to mainly focus on that first one.
Semantics. The meaning behind the what-if.
Right.
Yeah.
You got it. How do we even make sense of those two words? It's a deceptively simple question.
And it had some really big implications. Because how we understand counterfactuals actually impacts how we see huge debates like free will, rationality, mental representation, how our minds work, cause and effect, scientific explanation, even laws of nature.
Well, okay, so we're talking big stuff here, not just some niche philosophical puzzle.
Not at all. This is foundational stuff. By getting into the semantics of counterfactuals, we're unlocking a powerful way to understand all these other concepts.
I like it. Shortcuts to knowledge. That's what the deep dive is all about. So let's jump in, shall we? One thing our sources make clear right off the bat is that while the word counterfactual often implies something false, something that didn't actually happen, philosophers tend to use counterfactual conditional and subjunctive conditional pretty much interchangeably.
Right, and that's an important distinction for our listeners. Not all if-then statements about hypothetical scenarios start with something we know is false.
Exactly. And to really illustrate this, it helps to look at the difference between indicative and subjunctive conditionals. Our source uses this great example about Oswald and Kennedy. Let's say we have two statements. If Oswald didn't kill Kennedy, someone else did. And then if Oswald hadn't killed Kennedy, someone else would have. Now, even if we know Kennedy was assassinated, these two sentences have different vibes, don't they?
Good.
Okay, so imagine like a scenario where Oswald doesn't act, but some other person completely independently assassinates Kennedy. In that world, that first statement, if Oswald didn't kill Kennedy, someone else did, would actually be true.
Yeah, someone else did do it, just not because Oswald didn't.
Exactly. But the second statement, if Oswald hadn't killed Kennedy, someone else would have. That might be false. Maybe there was nobody else planning on doing it. You see, the way we frame these what-ifs actually changes the meaning, even if the past stays the same.
And you can hear that difference even in everyday language. There's this example in our source that's just so awkward. Bob never danced. If Bob danced, Leland danced. It just sounds wrong. But if we shift it to the subjunctive, Bob never danced. If Bob had danced, Leland would have danced.
Or if Bob were to dance, Leland would dance.
Exactly. Those sound perfectly fine. So indicative conditionals, they get weird when we deny their premise, like Bob never danced contradicts if Bob danced, but subjunctives handle that contradiction without a hitch.
And linguistically, we signal this difference through verb tenses, past perfect, present conditional, and words like would and were to. These little tweaks in language make a big difference to the meaning. Okay, so to keep things tidy when talking about these subjunctive conditionals, our source introduces a little bit of shorthand. It's phi. And that's basically just a way to say, if it had been the case that phi, then it would have been the case that, a bit of a mouthful. So that little symbol helps us talk about these what-if statements more concisely.
But as the source points out, this notation, it's a simplified tool. Like it kind of merges that if-then with the would into a single symbol.
Right, so it's useful, but it has its limits.
Definitely. For example, it doesn't handle more complex hypotheticals so well. Think about a statement like, if Maya had run, she might have been elected. Or remember that quote from Roosevelt about Taft, if he were to follow his conscience, he would return to the Republican Party. These examples involve modal terms like might or even have if-then clauses embedded within them. The simple just doesn't quite capture all that.
Gotcha. So it's a useful tool, but we got to remember it's just a tool.
Exactly.
Okay, so let's dive into how counterfactuals connect to agency, mind, and rationality. And the first stop on this train is agency, choice, and the big question, free will. It seems like the very idea that we make choices is wrapped up in a counterfactual, right? I mean, if I choose to eat an apple instead of a banana, doesn't that imply that I could have chosen the banana?
That's a really fundamental point. The sense that we could have acted differently is absolutely central to how we understand choice and, even more importantly, responsibility. And this, of course, throws us headfirst into the age-old debate of free will versus determinism.
Ah, yes, the classic showdown. If everything in the universe is already determined, by prior events and the laws of physics and all that, did we really have a genuine choice?
Exactly. And how we interpret that could have, in a counterfactual, like if I had wanted to choose the banana, I could have, directly shapes how we approach that whole debate. Our source points out that some philosophers, those called incompatibilists, generally believe that free will and determinism can't both be true.
Right, it's either one or the other. So an incompatibilist might argue that in a deterministic universe, that counterfactual about choosing the banana, it's actually false. Like not just false in a practical sense, but false in a fundamental physical way.
Yeah, and on the other side, you've got compatibilists who believe that free will and determinism can coexist.
Yeah.
They might argue that they could have, in that banana example, actually refers to a different kind of possibility, one that's still relevant to our experience of making choices, even if the universe is ultimately deterministic at a deeper level.
So essentially the meaning of could have becomes a battleground.
Precisely. The semantics of these counterfactuals directly impact how we even frame the free will problem. It's pretty fascinating.
And our source brings up a point about psychology, which is really interesting. People who believe in free will actually tend to engage in more counterfactual thinking.
Which makes sense, right? If you think you have genuine choices, you're more likely to ponder those what-ifs.
And reflecting on past decisions and events through those what ifs seems to help us find meaning in our lives too. Like it allows us to learn from mistakes and feel like we have control over our paths. It's all tied up in our sense of identity.
Right, and this is where it gets really interesting. Even someone who leans toward incompatibilism might admit that this human tendency to think counterfactually, to believe in free will, it serves a crucial psychological function. It's almost as if there's this pragmatic argument for believing in free will. It's so vital for how we function as human beings that maybe it's rational to believe it, regardless of its ultimate truth.
I like that. It's like saying, okay, maybe free will isn't real in some absolute sense, but it's so damn useful that we might as well treat it as if it is.
Exactly. And it makes you wonder, what does real even mean in this context? But that's a whole other deep dive, I think.
Okay, let's move on to rationality. Turns out, counterfactual thinking isn't just about agency and choice, it's also a cornerstone of what's called rational imagination.
Oh, yeah, that's a great way to put it. And this ability to envision alternatives, it's absolutely essential for acting rationally in the world.
So how does that play out in real life?
Well, think about forming rational intentions. Let's say a pilot is reviewing a near miss they had, and they're thinking, if I had understood what that air traffic controller was saying, none of this would have happened. They're using counterfactual thinking to plan for safer flights in the future. Or take a blackjack player reflecting on a hand they misplayed. If I had hit on that 16, maybe I wouldn't have busted. They're using those what-ifs to refine their strategy.
So it's about learning from experience, but through the lens of possibility.
Exactly. And there's real evidence for this. Studies in psychology show that counterfactual reflection actually leads to greater perseverance and improved performance in various tasks.
That's pretty cool. But I guess like anything, too much of a good thing can be a problem, right? Our source mentions that when counterfactual thinking gets excessive or distorted, it can lead to some mental health challenges.
Yeah, unfortunately, like depression and anxiety.
Mm.
It's almost like we can get trapped in those what-if scenarios, dwelling on all the ways things could have gone better or catastrophically worse. It can be really debilitating.
That definitely underscores how central this ability is to healthy rational functioning. I mean, too much and it's a problem, too little, and we can't learn from experience effectively.
It's all about balance. And philosophers have really grappled with this. Some even argue that being able to think counterfactually is part of what it means to be a rational agent, like it's a defining characteristic.
And there are these thought experiments in philosophy, right? Like Newcomb's problem. I remember learning about that in class. It messed with my head. But it definitely shows how crucial it is to consider counterfactual outcomes when making decisions.
Yeah, Newcomb's problem is a classic for a reason. It forces you to confront the limits of purely logical decision-making and how counterfactuals can really throw a wrench in the works.
It's like the universe is saying, you think you're so rational, well, try figuring this out.
Right. And there's also a connection between counterfactual thinking and how we rationally revise our beliefs, like how we update what we think is true when we encounter new information that contradicts our existing beliefs.
Because we have to imagine a scenario where that new information is true and see how it changes things. Right?
Exactly. It's like we're saying, okay, if this new information is true, what else would have to be true? And how does that change what I believed before? It's all about navigating different possibilities and figuring out which one makes the most sense given what we know. It's remarkably similar to how we consider the premises of counterfactuals.
Okay, now let's get into how counterfactuals relate to mental representation, the content of our thoughts, and even what constitutes knowledge. This is where things get really meta.
Yeah, we're going deep into the mind here. And for researchers in cognitive science and AI, understanding how we represent the world in our minds is a major focus.
Yeah.
And guess what? Counterfactuals play a big role.
Okay, so like how does that work? I mean, we're not just talking about what we believe or desire, but how our internal states actually lead to actions and choices in the world.
Right. It's about how we create internal models of the world that allow us to reason about cause and effect, about possibilities, about what might happen if we do this or that.
Our source mentions these things called Bayesian networks, structural equations, and causal models. These sound pretty sophisticated. How do they fit into this whole mental representation thing?
Well, imagine you're drawing a map of connected ideas. And the arrows on this map, they show how one idea influences another. A Bayesian network is like that map, but with probabilities attached to each connection. It's a way to visualize how likely things are and how changing one thing might affect the whole system.
So like how turning a key affects the probability of the car starting.
Exactly. Now, structural equations and causal models take this a step further. They explicitly model those cause and effect relationships, which are intimately connected to counterfactuals. Concepts like conditional probability, the likelihood of one thing given another, and probabilistic independence become super important here.
So we're going from simple maps to models that can simulate how things actually work in the world.
Exactly. And these models are not just abstract theories. They have real-world applications in AI systems like self-driving cars. They help us understand how humans learn, how we reason about cause and effect, all sorts of things.
And they even relate to that idea of embodied cognition, right? How our physical bodies and how we interact with the world actually shape how we think.
Oh, absolutely. And then there's this whole frame problem in AI. It's this classic problem of how artificial agents can efficiently update their understanding of a changing world. Like, how do they decide what information is relevant and what can be ignored? Counterfactuals and these causal models are really helpful for thinking about these issues.
That makes sense. It's like, if the world changes in a certain way, what other things would we expect to change as a result? Those are counterfactuals.
You got it. Now, it gets even more interesting when we think about the actual content of our mental representations. Like, how does the concept of cat, in my mind, come to represent an actual furry, meowing creature in the world? How do our internal states track information in the real world? This is where those informational theories of mental content come in.
And it sounds like counterfactuals play a role here too, right? Because just because two things happen together a lot doesn't mean one represents the other.
That's a crucial point. Like, a barometer falling doesn't represent rain, even though they're usually correlated.
Hmm.
So how do we distinguish genuine representation from mere correlation?
Yeah, that's tricky.
Well, some philosophers, like Lower, propose these counterfactual theories of information. The basic idea is that a state, in my mind, like my belief that there's a cat in the room, carries information about a cat if, under the right conditions, if that state occurred, if I believe there was a cat, then there would have had to have been a cat in the room. This gets around some of the problems that those purely probabilistic accounts run into.
So it's not just about correlation, it's about a deeper counterfactual dependency.
Exactly. If that mental state didn't guarantee the presence of a cat, like maybe I just hallucinated it, then it wouldn't really be representing a cat.
I see. It's about what would have to be true in the world for that mental state to be accurate.
Precisely. And then there's this other theory called Fodor's asymmetric dependence theory, which also uses counterfactuals to define representation. It focuses on these fundamental causal laws and how they determine what represents what. It's all really fascinating stuff.
It really is. It's amazing how this what if style of thinking keeps popping up in all these different areas of philosophy and cognitive science.
It's a powerful tool, and it doesn't stop there. It even helps us analyze knowledge itself, what it means to truly know something, especially when dealing with those tricky Gettier cases, where someone has a belief that's true and justified, but it still doesn't feel like real knowledge. But I think we can save that for another deep dive. What do you say we move on to how counterfactuals show up in metaphysics and scientific explanation?
Sounds good to me. And it seems like causation, what it means for one thing to cause another, is a prime example of where counterfactuals come into play.
Absolutely. It's a central topic in metaphysics, and a lot of philosophers have tried to define causation in terms of counterfactuals.
Like event A caused event B if and only if A hadn't happened, B wouldn't have happened either. Something like that.
You got it. That's the core idea, often attributed to David Lewis. Of course, it's been refined and debated a lot over the years, but it's a really influential starting point.
And those Bayesian networks and structural equations we talked about earlier, they're being used here too, right?
Yeah, those are really helpful tools for developing more precise accounts of causation. Thinkers like Hitchcock and Woodward have argued that structural equations, with their focus on how variables depend on each other, can be seen as representing fundamental counterfactual relationships.
So it's like if we change the value of one variable, like if we prevent event A from happening, the model allows us to see how that change ripples through the system and affects other variables. And those changes, those are the counterfactual consequences.
You got it. And what's really interesting here is that this framework isn't just limited to causation in the everyday sense. Some philosophers are using it to understand more abstract metaphysical concepts too.
Okay, like what?
We'll take grounding, for example. It's this idea that some facts are more fundamental than others and actually explain or ground those other facts. Like the fact that a table is made of wood might be grounded in the facts about the arrangement of its atoms.
Okay, I think I'm following. So how do counterfactuals come in?
Well, philosophers like Schaeffer and Wilson have argued that these grounding relationships, just like causal relationships, can be understood in terms of counterfactuals and modeled using structural equations. They say that if the grounding facts were different, the grounded facts would have to be different too. It's like a kind of dependency, but at a really fundamental level of reality.
Wow, that's pretty mind-bending. Using simile tools to analyze both how events cause each other in the world and how some aspects of reality are more fundamental than others. It makes you wonder what else we can analyze with counterfactuals.
Right. It's a really fertile area of research right now. And our source also mentions dispositional properties, which are another area where counterfactuals are super useful.
Okay, remind me what those are again.
Dispositional properties are those properties that describe what something would do under certain circumstances, like fragility. We say a glass is fragile because it would break if you dropped it, but it might never actually break if you never drop it. So the fragility is about its potential to break, not whether it actually does.
So counterfactuals help us capture those potentialities, things that could happen even if they never do.
Exactly. It's a way to describe the world in terms of what's possible, not just what's actual. And this brings us to scientific explanation and the laws of nature. It turns out these are super hard to separate from counterfactuals too.
Really? How so?
Well, think about it. Laws of nature, they feel different from mere coincidences. And one of the key differences seems to be that laws support counterfactuals, as philosophers put it.
What does that even mean?
Okay, so our source has this great example. There's a law of nature that all gold is malleable. You can hammer it into different shapes. This law supports the counterfactual. If that metal over there were gold, it would be malleable.
Okay, so even if that metal isn't actually gold, the law still tells us something about what it would be like if it were.
Exactly. But now contrast that with a mere coincidence, like every Canadian parent of quintuplets in the first half of the 20th century is named Dion. That's true, but it doesn't support the counterfactual. If some other Canadian had had quintuplets back then, they would have been named Dion too.
Because that's just a silly coincidence, not a law of nature. It doesn't tell us anything about what would have happened in other cases.
Precisely. So that's one way that counterfactuals help us understand what makes laws of nature special. They tell us not just about what is true, but about what would be true under different circumstances.
They have this kind of broader scope, a kind of modal power, as philosophers might say.
That's a great way to put it. And some philosophers, like Woodward, have argued that the essence of a scientific explanation is actually its ability to answer those what if things had been different questions. Like, why did the bridge collapse? Well, if it hadn't been built with those faulty materials, it wouldn't have collapsed. So the faulty materials explain the collapse.
So it's all about tracing those counterfactual dependencies back to the underlying causes.
Exactly. And others, like Mark Lange, have even proposed that laws of nature are somehow defined by their stability across certain hypothetical scenarios. Like, a true law of nature shouldn't be sensitive to minor changes in initial conditions. It should hold true in a wide range of counterfactual situations.
That makes sense. Laws of nature are supposed to be universal, right? They should apply across a wide range of possibilities.
Right, but then you also have views like Tim Maudlin's, who argues that we actually need to understand the laws of nature first to even figure out which counterfactuals are true in scientific explanations. It's a complex interplay between laws and counterfactuals.
Sounds like there's still plenty to figure out there.
Oh yeah, for sure. But I think it's time we move on to those semantic puzzles that our source delves into. This is where things get really tricky, even for philosophers.
Okay, bring on the puzzles.
All right, so it turns out standard logic, which works so well for connecting simple statements with and or not, it just doesn't handle counterfactuals very well. The truth of a counterfactual doesn't simply depend on whether it's if part and then part are actually true or false. More
Right.
complicated than that.
So it's not like basic math where we can just calculate the truth of a statement based on the truth of its parts.
Right. And a big problem is that you can have counterfactuals where both the if part and the then part are false, but the whole statement can be either true or false, depending on what it's about. Our source has this great example using Janis Joplin.
Oh, I love her.
Me too. Okay, so consider this. If Janis Joplin were alive today, she would drive a Mercedes-Benz.
Probably false. She always struck me as more of a Porsche kind of gal.
Right, but now consider this. If Janis Joplin were alive today, she would metabolize food.
Well, true, assuming she was a normal human being.
Exactly. But see, truth functional logic can't tell the difference between these two counterfactuals. They both have a false if part Janis is not alive and a false then part in the first case. But one feels intuitively true and the other false.
It's like the content of those statements matters in a way that basic logic can't capture.
Exactly. There's no logical operator like and or not that can take two false statements and sometimes give you a true result and sometimes a false result based on what those statements are about. This really throws a wrench in the works.
Yeah, it challenges that whole idea that counterfactuals are just about how things are in the actual world. Clearly, something else is going on.
Right. And then there was this influential philosopher, W.V.O. Quine, who was pretty skeptical about the whole project of trying to analyze counterfactuals semantically. He thought they were just too messy and context dependent.
So he was like, forget about finding some neat logical system for these things. It's a hopeless task.
Pretty much. He used these really tricky pairs of counterfactuals to illustrate his point, like the famous Caesar in Korea example. If Caesar had been in command in Korea, he would have used the atom bomb. Versus, if Caesar had been in command in Korea, he would have used catapults. Which one is true? It seems impossible to say.
It's like, how can we even evaluate those without knowing a ton about Caesar's personality, the specifics of the Korean War, all sorts of contextual stuff?
Exactly. And Quine thought this showed that counterfactuals aren't really about some objective truth out there in the world of possibilities. They're more about our own subjective judgments and how we imagine things could have been different.
So it's all about our own mental models and interpretations, not about some objective truth about counterfactual worlds.
Right. But then another philosopher, David Lewis, came along and argued that these examples don't actually prove that counterfactuals are meaningless. Instead, he said, they show that the truth of a counterfactual depends heavily on the context in which it's uttered.
So it's not that they're meaningless, it's that their meaning is context sensitive.
Exactly. The possibilities we consider when evaluating the if part of a counterfactual, they're shaped by the specific situation, the speaker's intentions, all sorts of pragmatic factors. This idea of context sensitivity has become really important in modern theories of counterfactuals.
It's like how the meaning of a word can change depending on how it's used in a sentence. Context matters.
Exactly. Okay, now are you ready for one of the biggest brain twisters in the world of counterfactuals?
Hit me with it.
All right, it's called Goodman's problem. And it really throws a wrench into things.
Lay it on me. I love a good philosophical wrench.
So Goodman pointed out that if you add more conditions to the if part of a counterfactual to the antecedent, it can actually change whether the whole statement is true or false, which is super weird.
Okay, how so? Give me an example.
The classic example is striking a match. Let's say we have the counterfactual. If I had struck this match, it would have lit. Seems plausible, right?
Yeah, matches usually light when you strike them.
Right. But now let's add a little something to the if part. If I had struck this match and done so in a room with no oxygen, it would have lit.
Well, that's clearly false. You need oxygen for combustion.
Exactly. So, by adding that extra condition, we flipped the truth value of the whole counterfactual from true to false. And this violates a principle called monotonicity that we see in standard logic.
Monotonicity. Sounds fancy.
It's not as complicated as it sounds. Basically, in standard logic, if you have a true statement and you add more information to it, the statement should still be true, like all dogs are mammals is true. And if I add, and all mammals are warm-blooded, it's still true.
Okay, so adding more stuff to a true statement should keep it true.
Right. But counterfactuals don't always play by those rules. Adding more to the if part can completely change the outcome.
So they're not monotonic. They can flip-flop on us.
Exactly. And this is a huge challenge for any theory of counterfactuals. It means they can't be analyzed using those nice, neat logical systems we're used to. Even basic forms of modal logic, which deal with possibility and necessity, don't have the tools to handle this kind of behavior.
So it's like logic is struggling to keep up with the weirdness of counterfactuals.
That's one way to put it. And Goodman, he didn't stop there. He raised another incredibly influential problem, which really gets to the heart of how counterfactuals work. He pointed out that whether a counterfactual is true seems to depend on a whole bunch of background facts and laws of nature. But trying to specify all those relevant background conditions without using counterfactuals ourselves seems practically impossible.
Right, walk me through that. What's the issue?
All right, let's go back to the match example. If I had struck this match, it would have lit. We said that's probably true. But what if the match was wet? What if it was made of some weird, non-flammable material? What if there was some bizarre chemical in the air that prevented combustion? There are all sorts of background facts that could make that counterfactual false.
Okay, so to really know if it's true, we need to consider all these potential background facts.
Exactly. But here's the catch. How do we even describe those background facts without relying on counterfactuals ourselves? Like we might say, well, the match needs to be dry. But what does dry even mean? We could say it means if you were to strike the match, it would light. But look, we're using a counterfactual to define the very condition that's supposed to help us determine the truth of the original counterfactual.
Whoa, it's like a snake eating its own tail.
Exactly. It's a potential circularity problem. And it gets even worse when we think about laws of nature, because we often describe those laws in terms of the counterfactuals they support. Like, all gold is malleable means if you were to try to hammer any piece of gold, it would change shape. So we're relying on counterfactuals to define the laws, but we need those laws to determine the truth of other counterfactuals. It's a tricky situation.
Okay, so to summarize these semantic challenges, we've got the fact that counterfactuals don't behave like those nice, simple and or statements. Their meaning changes depending on the context. Adding more to the if part can flip their truth value. And then there's this deep Goodman's problem about their dependence on background knowledge and laws, which might involve circularity. It's no wonder philosophers have been debating this stuff for centuries.
It's a really tough nut to crack. But these puzzles, they haven't made philosophers give up on understanding counterfactuals. If anything, they've become the central targets for contemporary theories.
So philosophers are like, challenge accepted.
Exactly. They're coming up with all sorts of clever ways to account for these unique features. And it's actually a really exciting area of research right now.
Okay, so before we wrap up, can you give us a quick overview of the different approaches out there?
Sure. So historically, there have been two main camps: strict conditional analyses and similarity analyses.
What are those all about?
Well, strict conditional analyses, they try to connect counterfactuals to logical systems that deal with necessity and possibility, called modal logics. They say that a counterfactual is true if its consequent then part is necessary given its antecedent the if part. But they've struggled to handle that non-monotonicity we talked about.
Right. Adding stuff to the if part can change the truth.
Exactly. Now, similarity analyses, they go in a different direction. They say a counterfactual is true if its consequent is true.